Welcome to our live leap year live stream. I have to say live twice. I'm Kim McDonald, and I am with our science writer, meteorologist to everything about space you want to know, Scott Sutherland.
Hello.
Hello. Everybody thinks they know about leap year, but
Right.
there are so many little details that we really don't know about leap year. And
That's right.
because it is February the 29th, we decided that this would be a good time to talk about it and get behind the science. So why do we have this extra day in February every 4 years?
Well, the basic reason is because although we track 365 days for our calendar, Earth's orbit around the sun is not 365 days exactly. It's a little bit more than that.
It all has to do with the relationship, the Earth with the sun, doesn't
Right,
it? Yeah.
exactly, yeah.
So how many, so it's not 365. We always, we teach our kids this. There's 365 days in a year.
Right.
But not exactly. So what is it exactly?
Exactly, it's 365 days, 5 hours, 48 minutes, and 45 seconds on average.
On average.
On average,
That's harder to teach.
yeah.
It's like pi.
Yeah. You only remember so many digits, but it keeps going forever.
That's right. Okay, so there's not exactly 365 days in a year, so we have to catch up at some point.
Right, and that's the whole introduction of the leap years, was to even that out so that we could account for that extra time and not have our seasons wander.
Right, I was going to say, okay, so what would the problem be
Right.
if we didn't do what we do?
If we didn't do what we do, eventually it would be really weird to be celebrating or to be observing our seasons in different months. So it would take a long time for it to do it, but if we didn't have leap years at all, say in the year 2000 we decided, that's it, no more leap years. By 2425 or something like that, we would be a full season off.
Wow.
Yeah, we'd be celebrating or observing spring, like we're coming up on soon. We would be doing that in December through March, not March through June.
Wow,
Yeah.
okay. Okay, so that would really throw us off. Our
Yeah.
seasons would be completely off kilter, which would be, I mean, some countries really don't see much difference in their seasons, but a place
Right.
like Canada
Oh, yeah.
definitely would.
Yes.
In northern areas of the US as well. So we're taking a look here at the future without leap years
Yeah.
and what it would look like. And yes, there's the seasons changing as the years go by. Now, what are the two rules of leap years? I didn't realize there were two rules, but there are two rules.
Yeah, so the first rule is pretty basic. It's just every 4 years, and it's the years that are evenly divisible by 4. So 2000, 2004, 2008, 2006, 12, 16, and so forth, till
Right.
2024, this year. Yes, we observe a leap year by adding 1 extra day. However, that accounts for 365 days and 6 hours. So we actually overcorrect by adding that extra day, one every 4th year. So you have to sort of correct the correction, or overcorrect the overcorrection.
Right.
I guess is
Yeah,
the best
yeah.
way to put it.
Let's bring it back a little bit.
Right, but you have to bring it back a little bit, and to do that, we skip some leap years. Every 4 centuries, we skip 3 leap years.
Every 4 centuries. Okay, so when was the last century that we skipped a leap year?
1900.
1900 on
Yeah,
the dot.
1900 on the dot, because the rule is if you divide, it's every 4 years, so every year that is divisible by 4 evenly, except if you can evenly divide it by 100, but not 400, then it's not a leap year.
Okay.
So 1900, you can easily divide that by 100, that's 19.
Yep.
But you can't evenly divide it by 400, so it doesn't count. 2000, on the other hand, can be evenly divided by both 100 and 400. So that is a leap year.
Okay.
And then 2100 will not be, and 2200 will not be, 2300 will not be, 2400 will be. So just those 3 missing leap years
Yes.
draws it back just enough, or evens it out just enough, that, I mean, there's still a little bit of wander. I mean, we're trying to shove these very, very rigid blocks of time, day, hour, so forth, into something that is almost never exact. Because
Right.
the orbit of Earth changes every year. depending on how the shape, where Jupiter is, where, how close we come to the sun, how far away we go. That always changes. So this is just, it's closer enough, I guess is the best way of putting it.
Okay.
It's not close enough, it's closer enough.
Closer enough, not
So,
perfect.
Not perfect. I don't think it will ever be perfect.
But we try.
We try.
We try our best. We're going to get to some questions in a moment. I just want to get into this a little bit because when we're talking about the relationship with the Earth and the Sun,
Yeah.
the equinox comes into place.
Right.
Into play. And the equinox is coming up.
Yeah.
In March, of course. So let's talk a little bit about the equinox and what that means and its relationship to leap day.
Okay, so that's actually kind of it's been the focus for leap years and leap days pretty much all along, is they want to keep our calendar oriented or synced up with the spring equinox. It seems like that's the one that is the focus for measuring the solar year, which is the time it takes for the sun in our sky. Not, we can't go above the solar system and look down. So we watch the sun in the sky, and when it returns back to its exact same place in the sky, that's a solar year after tracking through all the seasons. So, but we usually measure that from the equinox, from the spring equinox in March. So that's been the focus all along, is that we want to keep the spring equinox from migrating, because that will keep the other ones in place as well.
Okay.
Yeah.
And that's what we want.
Yeah.
Now, I've noticed, and a lot of people have probably noticed, when you count down the days until spring, and I'm one of those people who are like, okay, when is spring happening? And the equinox changes all the time. And this year, it is remarkably early.
Yeah, this is the earliest spring equinox in the last 128 years.
Okay, so I'm not imagining this.
No,
March
you're not.
19th.
Yeah, it's March 19th. It'll be 11:06 p.m. Eastern time. So it's still on March 20th for the Universal Coordinated Time, the Greenwich Mean Time. We'll still be on March 20th. But for us in North America, it'll be on the 19th, and that is the earliest it's been since 1896.
Wow.
Yeah. So and that's because of that slow creep backward in the day. Every 4 years, the equinox gets a little bit earlier, because we're overcorrecting with the leap day.
So the equinox won't be on the 20th anymore for the next foreseeable future, or the 21st. Is that what that means?
Not for us in North America, no.
Right. It'll always be on the 19th for the next
It'll keep
100 years?
Well, every 4th year it'll be on the 19th. Then the next year it'll be on the 20th again, because it advances by about 6 hours.
Okay.
And then it'll advance by another 6 hours after that, and another after that, and then we'll have a leap year, and it'll pull back to the 19th again.
Okay.
And we'll keep going with that pattern again and again over the years. Now, eventually, it will get to the point where it'll be 3 years out of every 4 are on the 19th. And that's when we start getting towards the end of this particular century, and we'll have the very earliest of all the equinoxes, I think possibly ever. I don't know about that part, but in 2096, it'll be like 10 a.m. Eastern time here in North America. And then we'll have the skipped leap year in 2100, and it'll push back onto the 20th. But that will be, again, we'll get into a pattern where it'll be 1 year of the 20th, and then 3 years of the 19th, and then 1 year of the 20th, and 3 years of the 19th, and then we'll have in 2100, it'll skip back to being the 20th all the time. So it will reset everything.
Okay, so
Yeah.
it's not stuck on the 19th.
Right,
Okay,
right.
I misunderstood. I was thinking we were going to get earlier and earlier because of leap year, and we're looking here at the days of the year and what happens with the equinox and with leap year. And I just want to, just as an aside here, I just want to quickly mention that we talk about meteorological spring
Yeah.
as March the 1st.
Right.
Our meteorological dates are different with seasons versus
Yeah.
what we have with the astronomical calendar,
That's
and
right.
that is because we like stats in meteorology.
Yes.
And because the date changes with the equinox, the solstice, et
Right.
cetera, between the 19th and the 21st, you can't get accurate data that way.
Right. Now, that started way, way back. Like, we're talking decades back when they were, everything was on paper, right? So when you were making all the calculations of I want the seasonal averages, temperatures, you didn't have a computer to do that for you. You had to do it yourself. Or maybe you had a calculator. But in those days, that's why it was instituted that March 1st is the first day of meteorological spring, and then June 1st for meteorological summer and so forth, because then you could make more accurate comparisons. Now, these days, it's nothing for a computer to run an astronomical seasonal average for weather. But in those days, and it's just carried forward, it was much, much easier to compare. You already had monthly averages. Then you could just translate that into a 3-month average to make that your season, because it matched perfectly, and just keep going like that. But that was a lot easier to do on paper. And it's just carried forward, as I said, until these days when, sure, you can just do it on the computer. You can do an average between any date and any time, and it doesn't matter. But this still carries forward that consistency to have those meteorological seasons.
Yeah, it helps.
It does.
Okay, so we got a lot of questions about the leap year and the equinox, so let's get to those questions.
Sure.
We will begin with question number 1, and here we go. Okay, so who came up with the idea of a leap year?
Now, I'm not sure if we know who came up with the original idea, but the first person who implemented the idea into our calendars was Julius Caesar over 2,000 years ago. That's when the Julian calendar was put into place. It's like 45 BCE, I think it was. So
wow.
Long time ago. And but that only included one leap year every 4 years, because at that time they didn't have extremely accurate timepieces and the right technology to be able to track the solar motion in the sky like that. So they knew that the year was 1/4 of a day longer than the calendar said. Mm-hmm. That's all they knew. So they said one extra day per every 4th year. Perfect. That we've solved the problem. No worries.
It's pretty incredible to think that happened that long ago, and that it was Julius Caesar, when they really didn't have the kind of tools that we have today.
Indeed.
So they did pretty well.
Yeah, and then 1,600 years later, that's when they figured out that, well, wait a minute, we're wandering away from the seasons again for some reason, and that's when they figured out the overcorrection, that we're 11 minutes and 15 seconds off, and so that's when they instituted those 3 skipped leap years every 4 centuries.
Okay, so somebody was doing the math. Okay, let's see what else we have here. What is the difference between the equinoxes and the solstices?
Okay, so the equinox is the exact moment that the sun appears above Earth's equator, because we're tilted in our axis. Our planet's axis is tilted by 23.5 degrees. So as we go around the sun, it's sort of like the sun goes higher and lower in our sky due to that perspective that we're getting. And any time at the exact moment that the sun appears right above the equator, that's an equinox. It happens twice a year. Mm-hmm. Once around March 20th, March 21st, that's vernal equinox. Well, it depends on what hemisphere you're in. Here in the northern hemisphere, it's the spring equinox, the vernal equinox. In the southern hemisphere, it'll be the autumnal fall equinox. And then you have another one around in September, which is the opposite. It's just a matter of what direction is the sun traveling in our sky. Yeah. Is it going from south to north? Then it's the spring for the northern hemisphere. If it's going north to south, then it's fall for northern hemisphere. The solstices are when the sun appears highest in the sky, is the summer solstice in June. And then the winter solstice is when it's lowest in the sky. And it's all, again, due to that tilted view that we have on the sun, where it looks like, from our perspective, even though it's smack dab in the center of the solar system all the time, it never moves, but it looks like it goes up and down in our sky, higher and lower in the sky.
Right, but it's just us. It's our perspective.
It's our perspective.
There's this little experiment that people like to do during the equinox, and we're going to prove whether it's truth or fact now with Leanna. Take a look.
Right.
You may or may not have heard of this one before, but according to the weather lore, during the spring and autumn equinoxes, it's the ideal time to try and balance an egg. An equinox happens when the sun passes directly over the Earth's equator. It results in a day and night that are exactly the same length, and it happens twice a year. The premise of this lore is that aligning the gravitational pull of the sun with that from the center of the Earth should somehow make it easier to balance any object. Popular objects include eggs and even brooms in some cases. But as has been proven before, the date and time really doesn't play a factor in balancing an egg. Simply the shape of the egg and the surface you're using. That's one weather lore that may not exactly be as advertised.
It probably depends on your table as well. No, okay.
And the bumpiness of the egg.
And the bumpiness of the egg. There's a lot. There's a lot going into
There's
that.
a lot going on, yeah.
Not quite the same. Okay, let's get to the next question. Okay, we talked about the difference between the equinoxes and the solstices. If the Earth had a round orbit, would we even need a leap year?
Right. Actually, we probably would, but it would depend. It depends on, is that round orbit exactly 365 days? Because the elliptical nature of our orbit usually just determines exactly how long our year is. So is it 365 days, 5 hours, 48 minutes, and 45 seconds, or is it just a little bit longer than that by like a few minutes?
Yeah.
Is it an hour later than that or an hour earlier? So having it be round, I don't think would eliminate our need for leap days. If it was that, but we were just slightly closer into the sun, and so it was exactly 365 days, then we wouldn't need it. It's just a matter of what is our orbit, how long does it take our orbit, whether it's circular or elliptical. So we probably would need them still if we just, right at this very moment, if we were somehow just able to stabilize our orbit in an exact circle, we would probably still need them.
See, that is a much more involved answer than I was anticipating that question, but that's how we do here at the Weather Network. Okay, so it depends, of course. That's a good scientific answer. When do you celebrate your birthday if you are born on February 29th? I had a great answer to this question from our social media manager, Rachel. She said, you'd have to celebrate it on March 1st.
Right.
Because the year you were born, you weren't alive on the 28th.
Right.
So March 1st, you were there.
That's very good. See, I was going to say both.
Sure,
For the 29th and the 28th and the 1st. But yeah, that makes a lot of sense.
And I mean, there are a lot of people who like to celebrate the entire month, and maybe, you can cross right over into March if you do, February and March. My friend's daughter is due any moment, any day, and she was really hoping the baby would be born on the leap year. I don't know why, but maybe, she only wants to buy a gift every 4 years. I don't know.
Right.
I don't mean that, I promise you. I know she doesn't mean that. Okay.
Right.
Let's talk about the role of leap year in maintaining the accuracy and synchronization in our calendar system. We talked a little bit about that. So we live and die by the calendar here, especially in North America. So again, let's just go back a little bit, and why is leap day so important for keeping our calendar on schedule?
Right, so if we did not have leap days once every 4th year, or thereabouts, our seasons would be completely out of whack with our calendar. Because Julius Caesar instituted it back with the Julian calendar in, just before we got into the current era, that was able to, at least mostly stabilize things. And then when the Gregorian calendar came along in I think it was the late 1500s, early 1600s, that stabilized it even further, because we needed to account for the extra time that it takes our planet to orbit around the sun, because it's slightly longer. It's about a quarter of a day longer than 365 days. So we needed to account for that, but we also needed to account for the fact that if we add an extra day, we're overcorrecting, because it's 5 hours, 48 minutes, and 45 seconds averaged. So we need to then remove 3 leap days every 4 centuries to sort of best sync us up. And that has kept our calendar at least reasonably stabilized and reasonably synced up to the seasons. And it will, at least conceivably, it will continue to do so in the future.
Okay, I have one more question.
Yeah.
why isn't the equinox an even 12 hours daylight and night? We always say that it's an exact even 12 hours of day and night, but
I mean,
it's not, is it?
Technically it is, which is interesting, but it's how we decide what sunset and sunrise is that throws it off kilter.
Oh, okay.
So when you see pictures from space, like the GOES weather satellite from NOAA, will have a picture from the equinox, and it will show how it's perfectly, there's a straight line up and down, both hemispheres, exactly the same amount of daylight on that day. But we count sunrise as being when the sun just crests the horizon. Just the tiniest bit of the sun crests the horizon, that's sunrise. Sunset is when the sun completely disappears beyond the horizon. So we're not going to get 12 hours of sunlight on the equinox, because even though it's perfectly lit, both hemispheres are getting the same amount of light. If we counted it so that halfway, when the sun is halfway set, or halfway risen as being the sunset and sunrise, then it would be 12 hours.
Okay.
So we do this to ourselves again.
It's all about our own perspective.
Yeah.
Human beings.
Yeah.
Who knew? Scott, I really appreciate all your insight into this. I learned more about leap years and leap day than I ever knew, and I always love hearing about the equinox because I look so forward to spring. And speaking of which, do not forget to check out our spring forecast. We have now released it here at the Weather Network. Tomorrow is Meteorological Spring, March the 1st, and if you are looking forward to this season, as I am, you can find all the details on theweathernetwork.com. We'll let you know what spring will be like wherever you live in this country. Thanks for joining us.